All right, our next notes video here, page 11 in our 7.3 notes, is about x-intercepts. So in our previous video, we talked about finding y-intercepts. This one we'll talk about finding x-intercepts. Really, these are the two important y and x-intercepts characteristics that show us how the middle of the graph works in a polynomial function. Okay. So to find an x-intercept, we're going to plug in 0 for y and solve for x. Something that we have talked many times about in previous notes videos and previous units. This could cause us to have to factor. The easiest thing would be if it's already written in factored form. Okay, like number 1 here. Number 1, this is written in factored form. Numbers 2 and 3 standard form. We're going to have to factor those. And then, just like in a couple previous units, to solve for our x values, we're going to think of that zero product property where we're setting all of our factors equal to 0. So let's start by plugging in 0 for y here in number 1, and we're going to solve for x. Zero product property, as we talked about, I'll underline that in red because that's what we're going to use here. We're going to take each one of the factors and set them equal to 0. I like setting the Gcf equal to 0, even if it's just a number, just to kind of check in. It's not going to give us another x-intercept unless there's an x out front there. But we can, technically we should set it equal to 0, but that one doesn't make sense. There's no x, that's not going to give us another x-intercept. But we do some simple algebra here. Subtract 4, subtract 1, add 3, add 1. We will get, in this case, 4 x-intercepts. We can list them as coordinate points. And that's how we would find our 4 x-intercepts in this case. Okay. These would be where the graph crossed the x-axis in terms of if you were to graph this, and we'll put all that stuff together by the end of the unit. Also, if we were giving you a graph and you were trying to identify where those x-intercepts were, you'd be able to do that. All right, so number 2, we'll again plug in 0 for y, excuse me. And let's underline our factor here, concept here in green. All right. We're going to find the GCF. So remember that the directions to all factoring problems, when we start factoring, we want to take out the GCF. We'll check to see if there is one. Now, each one has a variable, so we know we're going to have a variable as part of our GCF. Each one of these numbers are also divisible by 4. So our GCF here should be 4x. How do we figure out what remains from each term after we pull out the GCF? Well, we divide each term. So we'll get x squared minus 3x minus 10. All right, this equation is still equal to 0. We can't forget that. And now we should work to factor what remains. We look in here, we have an x squared, an x, and a constant. We have a trinomial. We want to look to factor that. We use our guess and check method here. We're thinking of some numbers that multiply to be negative 10. Options would be 10 and 1, 5 and 2. Hopefully at this point you feel pretty comfortable with our factoring that looking at the middle term would make sense for these to be 5 and 2. The middle term's negative, so I'm going to make the bigger of the two numbers, the 5 negative and that positive. We can even check our work here like we normally do. We multiply that outside term, 2x, the inside negative 5x. These do add up to our negative 3x, so we hit every part of this in terms of our factors. So I know that was just checking it. So let me rewrite our factors down here. And then our final step in red, let's use that 0 product property here to set each one of our factors equal to 0. And we'll get x equals 0. X equals 5, x equals negative 2, and then we have our 3 x-intercepts. All right. For the rest of the notes page here, page 11, what we'd like you to do is do number 3 on your own. think about whether it's in standard form or factored form. If it is in standard form, factoring it would be very useful. Then use that zero product property to find our x-intercepts. And then again, just like our y-intercepts page, let's use the bottom here as some practice in terms of matching which graphs go with which function.